Okay, so we're going to talk about function notation today. So in your TOC, put function notation and whatever page you're on. I don't remember what page I'm on. I'm at home in quarantine, so I'm just going to go with whatever page you have down. So a function can be thought of as a machine that assigns one output to every input. So an example of this would just be like, imagine you're making cookies and you make a certain amount of dough, you would expect a certain amount of cookies. If you double the amount of dough, you would expect to double the amount of cookies. So every time you put something in, it should have a unique answer in terms of its output. And we sometimes use a function machine to kind of like envision this, what goes in and then what is it going to produce coming out the other way. So what does function notation look like? So f of x equals 3x plus 4. This is an example of function notation. Now, obviously, these can change with the function. Okay, so it doesn't have to be the letter F. It can be the letter A, the letter G, the other letter M. So this first letter, we call that the name of the function. The X, we consider that to be the input. And a lot of times the reason why we're going to call it X is because we're going to find that because every input is going to have a unique output, we can put different inputs into the same machine and then we should get a different output. And with that, we should be able to graph that. So X would be the first input, would be on the horizontal axis of the graph. And our output, we often call Y, but in this case, we're going to call it F of X. So input tells what number or value, because sometimes we're going to be asked to put in an expression to substitute into the function. Okay, and oftentimes we're going to call these the X or the domain values, or domain element, or an element of the domain. Okay, so then down below, this whole piece together is the output. So when we see F of X, what we mean by that, it means the output of the function F when the input is X. And these create our Y coordinates or our range, our elements of range. And then this piece together is the function. Sometimes people like to call it the rule, right? This is telling you what needs to be done. So let's go ahead and look at this function and what that's going to look like with certain inputs and outputs. Okay? So when we see a function machine, we also often see a machine that looks like this. This is what a function machine looks like. And we're going to look at this function example up above. And the first thing we're going to do is we're going to find f of 2 for the function. So they're asking us to find f of 2 for 3x plus 4. Got the equal sign in there. So that means I need to take 2 and substitute it in wherever I have an input. So this is going to look like 3 times 2 plus 4. Well, I know 3 times 2 is 6 plus 4 is 10. So when the input was 2, the output was 10. Make this next one a little bit bigger. So what happens with this same function if they want me to find what happens when I put in a -1? So they're asking me to find f of -1 for 3x plus 4. So for the function f of x, we're looking at it when the input is -1. So f of -1 is going to be 3 times -1 plus 4. So 3 times -1 is -3, plus 4 is going to give me 1. So when my input is -1, my output in this case is going to be 1. Now you should notice in both examples, my input was 2, my input was -1. When I'm putting in the input, I always put it in parentheses so that I don't get confused with any of the signs around it. So we're going to continue on here. We're going to find f of 0 for 3x plus 4. So f of 0, I do that in a different color, equals 3 times 0 plus 4. So in other words, my input is going to be 0, and my output is going to be, in this case, 4, because 3 times 0 is 0, plus 4 gives me 4. We'll do one more here. So what happens when I'm going to input a 5? So I'm finding f of 5. So 3 times 5 plus 4. 3 times 5 is 15, plus 4 is 19. Now we can also organize this information, and sometimes this is just the way they give us, in a function table. Right? So it's just kind of recording what the machine does. So our input, our function machine, and our output. So if I was going to organize this information, I would make my input smallest to greatest. So -1, 0, 2, and 5. Now I can basically take each one from inside my function machine and put this in my table. So f of -1 equals, and usually up here we would have the rule, 3x plus 4. So 3 times -1 plus 4. F of 0, 3 times 0 plus 4. F of 2, 3 times 2 plus 4. I'm just rewriting the same thing that I wrote on each one of these machines. So sometimes when they want us to find multiple inputs for the same machine, they're going to give us the table versus making all these individual machines. So we know for -1, our answer was 1. For 0, our answer was 4. For 2, our answer is 10. And for 5, our answer was 19. The thing is, since each function, every input has its own output, when we write this table, we often are going to be able to find patterns that exist, which would help us find other values in the table if we wanted to expand it or go in between. And we're going to talk more about those patterns at a later date. But for now, this is what we want you to practice, is substituting into a function machine and determining your output from that. So in your digital notebook, you have GPs 1 and 2 to do that are on slide 4 and 5.